Hello, and welcome to the new podcast series of Climate Chronicles, Unraveling the Implications. In this first episode, we discuss about the science behind climate change. Now let's get started. Climate change is a complex and multifaceted challenge that affects our planet on a global scale. Understanding its scientific underpinnings is essential for grasping the urgency of the issue and finding effective solutions. By uncovering the scientific foundations of climate change, we aim to empower listeners with knowledge that can inform their actions and contribute to the broader effort to mitigate and adapt to this crisis. In this episode, we will first examine the causes of climate change. Human activities, particularly the burning of fossil fuels, deforestation, and industrial processes, release vast amounts of greenhouse gases into the atmosphere. These gases, such as carbon dioxide, CO2, and methane, CH4, act as heat-trapping agents, contributing to the greenhouse effect and leading to a rise in global temperatures. By understanding the causes of climate change, we can better comprehend the direct role that human actions play in shaping the Earth's climate system. Next, we will explore the mechanisms behind climate change. We will delve into the concept of the greenhouse effect, where certain gases in the atmosphere trap heat and prevent it from escaping into space. By understanding how greenhouse gases intensify this effect and contribute to global warming, we can appreciate the intricate processes at play. We will also discuss feedback mechanisms, both positive and negative, that can either amplify or dampen the impacts of climate change. This exploration will provide valuable insights into the complexities of the Earth's climate system and the interconnections between different components. To solidify our understanding, we will examine the evidence and research findings that support the reality of climate change. We will explore temperature records, ice core data, satellite observations, and climate models. By examining these sources of evidence, we can observe the trends of rising global temperatures, melting ice caps and glaciers, and shifts in weather patterns. These empirical findings contribute to the scientific consensus on the existence and human influence of climate change. Lastly, we will discuss the implications of climate change for our planet and society. We will examine the consequences of inaction, such as rising sea levels, increased frequency and intensity of extreme weather events, and disruptions to ecosystems and biodiversity. Understanding these impacts is crucial for recognizing the urgency of taking action and for developing strategies to mitigate and adapt to the changing climate. Through this exploration of the scientific foundations of climate change, we aim to inspire listeners to become informed advocates for change. By highlighting the crucial role of human activities in driving climate change, we emphasize the collective responsibility we share in addressing this global crisis. Join us as we unravel the implications of climate change and work towards a sustainable and resilient future for all. Now let's delve into the primary causes of climate change, shedding light on the significant role that human activities play in shaping the Earth's climate system. By examining the burning of fossil fuels, deforestation, and industrial processes, we aim to better comprehend the causes and their implications for our planet. The burning of fossil fuels, such as coal, oil, and natural gas, is a major contributor to the release of greenhouse gases into the atmosphere. When these fuels are combusted for energy production, carbon dioxide, a potent greenhouse gas, is emitted into the air. CO2 is particularly significant because it has a long atmospheric lifetime, meaning that once released, it can persist in the atmosphere for decades to centuries. The combustion of fossil fuels for transportation, electricity generation, and industrial activities has led to a significant increase in CO2 concentrations in the atmosphere since the Industrial Revolution. Deforestation is another critical factor contributing to climate change. Forests act as carbon sinks, absorbing CO2 from the atmosphere through photosynthesis. However, when forests are cleared for agriculture, logging, or urbanization, the stored carbon is released back into the atmosphere. Additionally, the loss of trees reduces the Earth's capacity to absorb CO2, exacerbating the greenhouse effect. Deforestation, particularly in tropical regions, has a significant impact on global CO2 levels and contributes to the overall increase in greenhouse gas concentrations. Industrial processes also play a role in climate change. Certain industries emit greenhouse gases as byproducts of their operations. For example, the production of cement releases substantial amounts of CO2 through the chemical reaction known as calcination. Other industrial activities, such as manufacturing and chemical production, release greenhouse gases like methane, CH4, and nitrous oxide, N2O. These emissions from industrial sources contribute to the overall greenhouse gas burden in the atmosphere. By understanding these causes, we can better grasp the impact of human activities on the Earth's climate system. The release of greenhouse gases from burning fossil fuels, deforestation, and industrial processes disrupts the natural balance of the atmosphere and intensifies the greenhouse effect. As a result, the Earth's temperature rises, leading to various climatic changes and subsequent consequences for ecosystems, weather patterns, and human societies. Recognizing the role of human activities in driving climate change is essential for acknowledging our collective responsibility to address this issue. By understanding the causes, we can begin to explore and implement strategies to mitigate greenhouse gas emissions, promote sustainable practices, and transition to cleaner energy sources. The understanding of these causes also highlights the need for international cooperation and policy interventions to effectively tackle climate change on a global scale. In the next sections of this episode, we will continue to explore the mechanisms and evidence behind climate change, further deepening our understanding of this complex phenomenon. Through this knowledge, we can empower ourselves to take action and contribute to the collective effort to mitigate the impacts of climate change, ensuring a sustainable future for generations to come. The greenhouse effect is a natural phenomenon that helps regulate the Earth's temperature and makes our planet habitable. However, human activities have intensified this effect, leading to global warming and climate change. To understand the greenhouse effect, we must first grasp the basic principles of radiation and energy balance in the Earth's atmosphere. The sun radiates energy toward the Earth through sunlight, which includes a wide range of wavelengths, including visible light, ultraviolet, UV radiation, and infrared IR radiation. When this energy reaches the Earth's surface, it is absorbed and re-emitted as IR radiation. Certain gases in the atmosphere, known as greenhouse gases, can absorb and re-emit this IR radiation. The most significant greenhouse gases include carbon dioxide, CO2, methane, H4, nitrous oxide, N2O, and water vapor, H2O. These gases have molecular structures that allow them to absorb and trap the heat energy, preventing it from escaping back into space. When solar energy reaches the Earth's surface, it is absorbed and re-emitted as IR radiation. Greenhouse atmospheric gases absorb some of this IR radiation, trapping it and causing a warming effect. This process is similar to how a greenhouse functions, hence the term greenhouse effect. Without the greenhouse effect, the Earth's average temperature would be much colder, making it unsuitable for sustaining life as we know it. However, human activities have significantly altered the natural balance of greenhouse gases in the atmosphere. Burning fossil fuels, deforestation, and industrial processes have led to a substantial increase in greenhouse gas concentrations, particularly carbon dioxide. As these concentrations rise, more heat is trapped in the atmosphere, resulting in a net warming of the Earth's surface and the lower atmosphere. The consequences of an intensified greenhouse effect are evident in the observed global warming trends. Earth's average surface temperature has been rising steadily over the past century, with the rate of warming accelerating in recent decades. This warming has far-reaching impacts on the climate system, including changes in weather patterns, rising sea levels, and biodiversity loss. Understanding the mechanics of the greenhouse effect is crucial for comprehending how increasing greenhouse gas concentrations contribute to global warming and climate change. As human activities continue to release large amounts of greenhouse gases into the atmosphere, the enhanced greenhouse effect amplifies the warming trend, with potentially catastrophic consequences for our planet and its ecosystems. In the next sections of this episode, we will further explore the mechanisms and consequences of climate change, including feedback loops and the evidence supporting the reality of global warming. By unraveling these complexities, we can gain a deeper understanding of the urgent need to address climate change and work towards sustainable solutions that mitigate the impacts of the greenhouse effect. Feedback mechanisms can be broadly classified as either positive or negative. Positive feedback loops tend to amplify the initial climate change signal, while negative feedback loops work to counteract or mitigate the effects of climate change. One notable positive feedback loop is the ICE albedo feedback. Albedo refers to the reflectivity of a surface, with lighter-colored surfaces reflecting more sunlight back into space. As global temperatures rise, ice caps and glaciers melt, reducing the Earth's overall reflectivity. With less ice to reflect sunlight, more solar energy is absorbed by the Earth's surface, leading to further warming. This process creates a self-reinforcing cycle, as the warming leads to more ice melting and less reflection, amplifying the initial warming signal. Another positive feedback loop involves the release of greenhouse gases from natural sources. As the Earth warms, permafrost regions thaw, releasing trapped methane and carbon dioxide. Methane, in particular, is a potent greenhouse gas that contributes to additional warming. This release of greenhouse gases from natural sources adds to the atmospheric greenhouse gas concentration, intensifying the greenhouse effect and leading to further warming. In contrast, negative feedback loops can help mitigate the effects of climate change. One example is the carbon cycle feedback. As atmospheric CO2 levels rise, plants and oceans absorb more carbon dioxide through photosynthesis and oceanic uptake, respectively. This uptake acts as a natural sink for carbon dioxide, reducing its concentration in the atmosphere. Additionally, increased plant growth due to elevated CO2 levels can enhance carbon sequestration, further offsetting the effects of human emissions. Another negative feedback loop involves the role of clouds. Clouds reflect incoming sunlight back into space, thereby reducing the amount of solar radiation that reaches the Earth's surface. As temperatures rise, the formation and distribution of clouds can change, altering their overall reflective properties. This change in cloud cover can have a cooling effect, helping to counteract some of the warming caused by greenhouse gases. Understanding these feedback mechanisms is crucial for comprehending the complex dynamics of the climate system. Positive feedback loops can lead to the amplification of the initial warming signal, potentially resulting in more severe climate impacts. Conversely, negative feedback loops provide a degree of self-regulation, mitigating the effects of climate change. By studying these feedback mechanisms, scientists gain insights into the potential tipping points and thresholds that could trigger abrupt and irreversible climate changes. Understanding the delicate balance between positive and negative feedback loops can inform mitigation and adaptation strategies, helping us to develop effective measures to address climate change and minimize its impacts. In the following sections of this episode, we will further explore the evidence and research findings that support our understanding of climate change and its implications. By unraveling the complexities of feedback mechanisms and their role in shaping our climate, we can better appreciate the urgency of taking action to address the global climate crisis. Now let's explore the wealth of evidence and research findings that support the reality of climate change. By examining temperature records, ice core data, and measurements from satellites and climate models, we can strengthen our understanding of the ongoing global warming trend. First, temperature records. One of the most compelling pieces of evidence for climate change is the long-term analysis of temperature records. Over the past century, global average temperatures have consistently shown an upward trend, with the last few decades being the warmest on record. This warming trend is evident across various regions and is supported by data from meteorological stations, buoys, and ocean-based instruments. Second, ice core data. Ice cores extracted from polar ice sheets and mountain glaciers provide a valuable source of information about past climate conditions. By analyzing air bubbles trapped in the ice, scientists can determine the atmospheric composition and temperature of different periods in history. These ice core records reveal a strong correlation between greenhouse gas concentrations, such as carbon dioxide and methane, and global temperature variations. The data from ice cores provide a historical context and demonstrate the significant influence of greenhouse gases on the Earth's climate. Third, satellite measurements. Satellites equipped with advanced sensors and instruments provide an invaluable tool for monitoring various aspects of the Earth's climate system. Satellite data allows us to observe changes in temperature, sea level, ice cover, vegetation patterns, and other critical indicators of climate change. These measurements provide a comprehensive and global perspective, enhancing our understanding of the Earth's climate dynamics. Fourth, climate models. Climate models are powerful tools used by scientists to simulate and project future climate scenarios. These models incorporate numerous factors such as greenhouse gas emissions, atmospheric conditions, ocean currents, and land use changes to simulate the Earth's climate system. By comparing model predictions with observed data, scientists can evaluate the accuracy of the models and gain insights into future climate trends. The agreement between model simulations and observed data provides further evidence of the human-induced climate change. Fifth, scientific consensus. It is crucial to highlight that the overwhelming majority of climate scientists agree that climate change is occurring and is primarily driven by human activities. This consensus is based on rigorous research, peer-reviewed studies, and the accumulation of scientific knowledge over several decades. Scientific organizations, such as the Intergovernmental Panel on Climate Change, IPCC, continuously assess and synthesize the scientific evidence to inform policymakers and society at large. By examining the scientific consensus and the wealth of empirical data, we can reinforce the importance of acknowledging climate change as a global challenge. The evidence from temperature records, ice core data, satellite measurements, and climate models all converge to support the reality of global warming and its anthropogenic causes. In the following sections of this episode, we will delve deeper into the implications of climate change, including its impact on ecosystems, human societies, and the urgent need for action. By exploring these strategies, we aim to inspire listeners to take part in collective efforts to mitigate the impacts of climate change and build resilience in the face of its consequences. Number 1. Mitigation strategies. Mitigation strategies focus on reducing greenhouse gas emissions to limit the extent of climate change. These strategies involve transitioning to cleaner and renewable energy sources, improving energy efficiency, and adopting sustainable practices across various sectors. Some key mitigation strategies include: Number 2. Renewable energy adoption. Promoting the widespread adoption of renewable energy sources, such as solar, wind, and hydroelectric power, can significantly reduce greenhouse gas emissions associated with fossil fuel-based energy generation. Number 3. Energy efficiency improvements. Implementing energy-efficient technologies and practices in buildings, transportation, and industries can help reduce energy consumption and decrease emissions. Number 4. Sustainable land use. Encouraging sustainable land management practices, including reforestation, afforestation, and conservation of natural habitats, can enhance carbon sequestration and mitigate the loss of natural carbon sinks. Number 5. Circular economy. Transitioning to a circular economy model that promotes resource efficiency, recycling, and waste reduction can reduce emissions and minimize the carbon footprint of economic activities. Number 6. Adaptation strategies. Adaptation strategies aim to reduce vulnerability and enhance resilience to the impacts of climate change. These strategies involve planning and implementing measures to adapt to changing climatic conditions and protect communities and ecosystems. Some key adaptation strategies include: Number 7. Enhancing infrastructure resilience. Upgrading and retrofitting infrastructure systems, such as transportation networks, water management systems, and coastal defenses, to withstand climate-related hazards, such as extreme weather events and sea level rise. Number 8. Nature-based solutions. Utilizing nature-based solutions, such as restoring wetlands, protecting coastal ecosystems, and creating green spaces, enhance resilience and provide multiple benefits, including flood protection, carbon sequestration, and biodiversity conservation. Number 9. Climate-resilient agriculture. Promoting sustainable and climate-smart agricultural practices, such as precision farming, crop diversification, and water-efficient irrigation, to adapt to changing climatic conditions and ensure food security. And finally, number 10. Climate information and early warning systems. Establishing robust climate information systems and early warning mechanisms to facilitate informed decision-making and proactive responses to climate-related risks and hazards. In conclusion, through understanding the causes, mechanisms, evidence, and consequences of climate change, we can grasp the urgency of the global climate crisis and the need for action. We all must play a role in taking action to address climate change by adopting sustainable practices in our daily lives, advocating for policy changes, supporting renewable energy initiatives, and engaging in community resilience building efforts. We can contribute to a sustainable and resilient future for all. Thank you for joining us on this journey through Climate Chronicles, unraveling the implications. Together, let us work towards a better future where we prioritize the health of our planet and ensure a sustainable and prosperous future for current and future generations. Remember, addressing climate change requires a collective effort from individuals, communities, businesses, and governments worldwide. By raising awareness, fostering dialogue, and taking concrete steps towards reducing our carbon footprint and building resilience, we can significantly mitigate the effects of climate change and preserve the planet for future generations. As we conclude this episode of Climate Chronicles, unraveling the implications, we encourage you to stay informed and engaged. Stay curious, seek out reliable sources of information, and continue exploring the multifaceted aspects of climate change. Together, let us take action, inspire change, and be a part of the solution to combat climate change. Thank you for joining us on this enlightening journey on Academia World News. In the next episode, we will discuss about climate change and biodiversity loss. Stay tuned as we unravel the implications of climate change and explore the possibilities for a sustainable and resilient future in this podcast series. Together, we can make a difference and shape a better world